So this brings us to the Keynesian model. In the Keynesian model, we are implicitly, or not even implicitly, we are definitely, whether it's implicit or explicit, dealing with a short-run model. So when we compare the short run to the long run in microeconomics, can you remember in micro what the difference between the short run and the long run was? Any takers? Short run, long run? Microeconomics? No? Okay. Are you happy that in the short run, the quantity of capital was fixed? Quantity of capital was fixed in the short run in microeconomics. Does that make sense? Is this ringing a bell to you? In the long run, the quantity of capital was variable. The quantity of labor was also variable. In the short run, the quantity of labor was variable. Quantity of labor variable, quantity of capital fixed. Everyone with me? That was how we distinguish short run and long run in microeconomics. In macroeconomics, in the short run and the long run, the how do I put this? Capital, quantity of capital in the short run and quantity of capital in the long run is fixed. Okay? Quantity doesn't change between short run and long run. That's not how we distinguish short run and long run in macroeconomics. Okay? Quantity of labor is also fixed in the short run and the long run. Okay? So what distinguishes the short run and the long run? Well, in the short run, prices are fixed, and in the long run, prices vary. Okay? And then there's kind of like another, we can call it the very long run in macroeconomics. And in the very long run, quantity can vary of capital, quantity of labor can vary, and prices vary. Okay? I'll come back to this once we've spoken more about the different kinds of models. I'm almost certain you'll forget this. Anyway, what we're dealing with at the moment is the short run. What does that mean in macroeconomics? It means that prices are fixed. That's what's important. Okay? Prices don't change. So what are our objectives in this chapter? We're going to introduce something, a distinction between planned expenditure, okay, and show how that's related to GDP. Again, here, price level is fixed, price level is fixed. It's a short run model. Then what it says here is calculate the values of the various expenditure components. All right, that basically just means when we had our equation y equals c plus I plus g plus x minus m, in this chapter what we're going to do is work out when we change these various values, what happens to y. Okay? Illustrate and calculate the expenditure multiplier. What is the multiplier? Well, when we change these things, C, I, X, G, M, it changes Y, but the relationship is not 1 to 1. It's not like when I increase investment by 10, I increase output by 10. No. When I increase investment by 10, I increase output by 100. Okay? Why does it increase by much more? Because of this thing called the multiplier. So we're going to talk about the multiplier. And ultimately, this all hinges on the relationship between aggregate expenditure and output and aggregate demand. Okay? So there's a relationship between aggregate expenditure and aggregate demand. The relationship between aggregate expenditure and aggregate demand is because there is also a relationship between aggregate expenditure. Let's go like this. Aggregate expenditure and output have a relationship as well. Okay, so we're assuming all prices are fixed. Price level is fixed. And what we want to do is we want to determine the level of real GDP, in other words, the amount of output when prices are fixed and the amount of output that is demanded. We're dealing with the demand side. We're not talking about supply. We're not talking about firms manufacturing things. We're saying if prices are fixed, how much output would people want to buy? Okay? If prices are fixed, how much do people, well, let's say actually not people, households want to buy? Okay? And the way we're going to do that is using this thing called the Keynesian Model. And the important aspect of the Keynesian Model was that it's trying to explain fluctuations in aggregate demand. What do we mean by fluctuations in aggregate demand? Well, remember that in our first chapter 23, when we plotted GDP against time, we saw that kind of goes like this, right? So over time it tends to go up, but in the meantime it's kind of going up and down and up and down. It's fluctuating, okay? So one of the questions of classical economics was, why does it do this? Why is it fluctuating, okay? And there was no real answer for why it was fluctuating in classical economics. And so Keynes came along with a story about why it fluctuates. Okay? And he said one of the reasons that it fluctuates is because prices are sticky. Okay? Prices being sticky means that they don't adjust when they're supposed to adjust. They don't adjust as quickly as they're supposed to adjust. And in fact, if we assume that prices don't adjust at all, then that's the stickiest they could be, right? So that's where we start. Prices are fixed, they're as sticky as they can be. Imagine prices don't change, what happens? Keynes is going to show that output can fluctuate. Okay. So here's our first concept, planned expenditure. It's an important concept, and I feel like most people that do the course just don't get the planned expenditure is in fact one of the central point of this model. Okay? And I think generally when people do this model, they are not really aware of what's driving the dynamics. They're not really aware of how this thing is working, and it all has to do with planned expenditure. So I want to just emphasize this. When we have planned expenditure, okay? In fact, let me go one slide forward, do a big discussion, and then come back and emphasize what is being stated in those two paragraphs, because I think they're important. At the beginning of your chapter, it makes the following statement. Sorry, anyone that's following the slides, I've rearranged the slides because they were all kind of clumped together, and I don't know, some of them didn't make much sense the way they'd put the diagrams with the text. So I've just rearranged them slightly. It's the same slides, I've just rearranged them a little bit. Okay? So, in your text, it makes the following statement. There's a two-way link between aggregate expenditure and GDP. What is the nature of this two-way link? Well, an increase in real GDP increases aggregate expenditure, and an increase in aggregate expenditure increases real GDP. And then it says this chapter is going to explain what that means. I don't think that it really makes very clear what the explanation is. I could be wrong. It's just when I read it, I don't get that. Here's the deal. You will have, in fact, let me make this a bit smaller. You will have seen the following equation. And we've said the way that we measure output, one of the ways we can measure output is in terms of what people spend in the economy. Okay? So this is the expenditure approach to measuring GDP. What we're going to do in this chapter is we're going to break down this component C into, well, let me just do it like this, hang on. Two parts. We're going to say that consumption itself is equal to little variable A plus another variable B times Y. And what this is telling us is that when we consume, the amount that we choose to consume, right, has a component that is dependent on income as well as a component that is not dependent on income. Okay? This number B here is normally a fraction, like for example 0.7. Okay? What our little equation here, our consumption equation, is telling us is if our income goes up by some amount, let's say income goes up by 1, so if it changes by 1 rand, if our income increases by 1 rand, how much are we going to spend of that 1 rand? We're going to spend 0.7 of that 1 rand. In other words, we will spend 70 cents. You happy with me? If our income changes, we will spend 70 cents of that change in income, of every rand of that change in income. What happens to the remaining 30%, 30 cents? That gets saved. You happy with that? If we consume 70%, then we must save 0.3 of that change in income. Okay? This little A over here just says this is the amount that we consume regardless of our income. Okay? There's a number of ways you can think about this. But a way that I think is pretty relevant to the South African story is there are plenty of households within the economy, within our country, that earn zero income. No income. Those households still spend money. You happy with what I'm saying here? Like, in other words, everyone needs to spend money even if you're not earning an income. You have to buy basic stuff, like food. Okay? And regardless of whether you're earning any income, you have to spend some money. Now, the amount of money that you can spend, this A, depends a lot on what kind of wealth you already have. Okay? Regardless of your income. So you could come from a very wealthy background, earn zero income, and have a high level of expenditure just because you've got a high level of wealth that you just draw down constantly, right? Or you can come from a household that has basically zero wealth, right? And it needs to rely on other sources of expenditure, not income. Okay? Either way, there is some amount that every household is going to be spending regardless of income. Everyone happy with that idea? So there's the amount of consumption, expenditure that depends on income, that's this part here, and there's this part that does not. So this part, consumption that depends on income, and this portion here which does not depend on income. And what we usually say is this depends on other things, for example, wealth. But anything that is not income. So it could depend on past savings. Either way, it's not income. So that's the one change, or the one extension to this equation that we've seen before, is that we're going to make this variable here, C, a little bit more complicated. The other change is that we're going to introduce another equation, and this equation looks really, really, really similar to what we've seen before. Okay? We're going to introduce something called aggregate expenditure, and aggregate expenditure is C plus I plus G plus X minus M, which looks a lot like this equation over here. It's actually different. Okay? They're two different equations. And what makes them different is, in fact, this term here. Even though it looks the same in both equations, really this should be written as IP. In other words, this is planned investment, and this is actual investment. So when we talk about this equation, we talk about aggregate expenditure, what we're actually talking about is aggregate planned expenditure. Oh no. Oh man. Okay, aggregate planned expenditure. Now, when our investment, which is to say our actual investment, is equal to our planned investment, okay, then our two equations are equal. In other words, Y is equal to aggregate expenditure. Okay? Everyone with me? Any questions? Anything you want to clarify? You happy? Yeah.
So all the other variables are the same?
Yeah.
So it's only R.
Yes. So when we deal with C here, we're going to be dealing with the same C over here. So going back one slide, planned expenditure. Aggregate expenditure has four components: consumption, investment, government spending, and net exports. What's important about this is when we talk about investment here, it is planned investment. Sorry. I see that. Sorry. I've done it on the wrong one there. Let me just get rid of that. So, aggregate expenditure versus aggregate planned expenditure. When we talk about planned levels, okay, and the thing that is unplanned is investment, okay? So when they talk here, aggregate expenditure has these four components. In other words, aggregate expenditure, when we're dealing with Y in terms of the expenditure approach, okay, versus, so this is aggregate expenditure measurement of Y, okay, versus aggregate planned expenditure, okay. And when aggregate planned expenditure equals actual aggregate expenditure, then Y, aggregate expenditure, Y equals AE, okay. So I prefer to just cross that out there and just put here output. In other words, Y. Y has four components. Output has four components. Okay? At the point where they are equal, their output will equal aggregate expenditure. In other words, aggregate planned expenditure. Okay? That's the setting. What we're going to do now is develop the model. The model that we are developing is, it's called the Aggregate Expenditure Model. In other words, we're dealing with this equation over here, but we're dealing with this equation in relation to this equation. But we're going to start by talking about aggregate planned expenditure. Okay? So when we deal with consumption and savings, and these are planned savings, what are the things that are going to influence our consumption and our savings? Well, it's going to be our disposable income, the interest rate, wealth, and our expected future income. So remember from our loanable funds market, we saw that savings was dependent on expected future income, wealth, interest rates, and income. So these are all the same factors that we've seen previously. Nothing new. We're just going to look at them in a different setting. The relationship between consumption expenditure and disposable income is called the consumption function. The relationship between savings and disposable income is called the savings function. In order to understand this better, we need to also describe or define what we mean by disposable income, which we will do in a moment. So here's our consumption function. In other words, the relationship between disposable income, okay, and the level of consumption level of consumption. The amount of consumption and disposable income, the relationship is called the consumption function. It is upward sloping and it's linear. Our savings function, the same story. The relationship between disposable income and savings, it's an upward sloping function, it's linear. Our consumption function has a positive intercept. Our savings function has a negative intercept. And what this diagram, what this line, this function is showing is in fact exactly the equation that I showed earlier. C is equal to A plus B y. Okay? Except that the y that they are talking about here is slightly different. We call it yd. And what do we mean by yd? Yd means y minus t. Okay? If we assume there's no taxes, so if taxes are 0, then it's just C equals A plus B times Y. If taxes are not 0, then C equals A plus B times Y minus T. Okay? Remember we saw that that in terms of the income approach, Y is equal to C plus S plus T. In other words, Y minus T is equal to C plus S. Right? In our consumption function, A, I said was the amount of consumption even if you've got 0 income. So where would A be on our graph? It would be our intercept. Surprise, surprise. We've got a linear function. C is a function of Y. Here's the intercept. Okay? What does this look like if you've been through the schooling system, which you have, so I know you've seen this before. Y is equal to mx plus c. That is equation for a linear function. What is c? C is the value of the intercept. What is m? M is the value of the slope. Okay? Here's our equation. C equals A plus BY. A is the intercept. B is the slope. There you go. Okay, so this is B. And we call B the MPC, which stands for marginal propensity to consume. the inverse of our consumption is our savings. If our income is 0, but we are consuming A, what would our savings be? Negative A. You happy with that? And as our income increases, we consume 70% of our income, which means we must save the remaining 30%. Okay? If our slope is b equals 0.7, then what is the slope of this line? The slope of our savings curve must be 1 minus b equal to 0.3. So the equation for our savings curve is S equals minus A plus 1 minus B times YD. YD being disposable income. Okay? Let's combine our consumption and savings equations here. So if we had C plus S, are you happy that would be equal to A plus BYD plus minus A plus 1 minus BYD. Okay? Are you happy that this would be A cancels with minus A plus B cancels with minus B, and I'm left with C plus S is equal to YD. And what is YD? Y minus T. Happy that it all fits together? Same as what you saw in chapter 23. We've just added a few more elements. Any questions? Everyone happy with that so far? Okay. So we've got a consumption function, we've got a savings function. Both of these functions are functions of disposable income. Disposable income means output, or Y, income, Y, minus T, taxes. I already mentioned that the slope of the consumption function is called the marginal propensity to consume. We represent that with the symbol B. It's the fraction of a change in disposable income that is spent on consumption. Okay, so let's go back to our standard Y equals mx plus c. Delta y over delta x equals m. What is m? It means that if I change x by some small amount, y will change by some amount called, or by some amount with the value m. Remember this? Okay. Same with our consumption function, sorry. I'll just write it down here. C equals a plus b y d. Change in C over change in yd equals b. It's the fraction of a change in disposable income that is spent on consumption. In other words, a change. If income changes by some amount, consumption will change by some amount to the value of b. In other words, change in C equals B times change in YD. Okay? And the marginal propensity to save is obviously just the inverse of that. It's the fraction of change in disposable income that is saved. So if we look at our consumption function, let's first add a 45-degree line to this diagram. What does a 45-degree line represent? It is the combination of all the points right, that have an equal x and and y intercept. Okay, 45-degree line means that all your points, all your x and y values are the same. It's the locus of all x, y combinations where x equals y. Okay, so the 45-degree line is where disposable income, which is our x value, equals consumption. That's what the 45-degree line means. Okay? So if we've got a consumption function and our consumption function lies above that 45-degree line, what does that mean? Anywhere along our line here, if our consumption function is above the 45-degree line, it means that C is greater than income. Does that make sense? Mathematically, are you happy that this is all relatively straightforward? If C is greater than income, if consumption is more than what we are earning, what must be happening to our savings? Our savings must be negative. In other words, our savings function must lie below 0. Until we reach the point where consumption equals disposable income. At the point where consumption equals disposable income, what is our savings going to be? 0. Once our consumption function lies below the 45-degree line, okay, are you happy that this must be an area where if consumption lies below disposable income, savings are therefore positive? You happy with that idea? Now, obviously, I've drawn a consumption function here with a slope that is less than 1. The slope of the 45-degree line, right? Slope must be equal to 1 because it's a 45-degree line. And my consumption function, what do I know about the value of B? It's the amount of income. Where is it defined? Sorry, here we go. It is the fraction of a change. In other words, for a change in income, there will be a change in consumption, and it's going to be a fraction. B is a fraction. It's going to be less than 1. If it's less than 1, the slope must lie at some point above the consumption function. The slope is less than 1, so that means that the consumption function must lie above the 45-degree line at some point and below the 45-degree line at some point, as long as we have a positive intercept. If A was not positive, then our consumption function would just sit below the 45-degree line at every point. In which case we would just always have positive savings. So the slope of the consumption function is the marginal propensity to consume, and the slope of the savings function is the marginal propensity to save. How do you guys feel about what we've done so far? Everyone happy with it? Okay, let me get what I'd like you to do. We're going to stop there, and I want you to just put this together yourself. So if you got a piece of paper and a pencil and a pen, a pen or a pencil, and I'm going to ask you a question, and I'd like you to draw a diagram. Okay? So get out your stuff. We're going to do a quick exercise to end the lesson, and then we'll continue with this, not next week, but the week after. We'll continue this tomorrow and finish it. Yeah? Yes.
Where is the most ideal place to be on the consumption graph? Is it below the 45-degree line?
I think the kind of question that you're asking is related to something like this aggregate expenditure curve here. Okay. And then you're asking the ideal spot. I'm not sure exactly what you mean by an ideal spot, but the point that we're interested in is the point where these two intersect. Okay? So again, I'm not 100% sure what you mean by ideal. Maybe think about that. But what we are interested in is the point where the aggregate expenditure curve, which is made up of the consumption function, crosses that 45-degree line. That is the point we're interested in. So in terms of ideal spots, anywhere else on the line represents an imbalance in the system. Okay? And the system itself, to balance itself, is going to move towards that point of intersection. And so I think that would be the ideal spots, given what you said. Yep. Okay, so if you've got a piece of paper and a pen, here's the question. I'm going to give you a consumption function. This is what it's going to look like. Sorry, let me draw it. Okay, I'm giving you a consumption function, and the values of A are 10, and the values of B is 0.5. The value of T is 0. Okay? What I would like you to do is to plot the consumption function. I would also like you to plot the savings function. Then, once you've done that, so that's number one. Number two, I would like you to change the values. So A is going to change to 15. Okay? And I want you to show that on your graph. So show change in A on your graphs. Okay, cool. So it shouldn't take you more than 2 minutes to do it. If you've got any questions, raise them. And I'll just in 3 minutes' time, I will quickly draw what you should have drawn. Okay, so take this as your opportunity to practice what we've done so far.